What's going on, everybody? Chris Winarski. We're back again with a welding fabrication video for everybody. My previous video I did was benefits of a welding fixture table, and this is an older video I have that's just been sitting in my app for a while that I haven't edited yet, and I just want to do a little video that you do not need a fixture table, and it's not required. It's definitely helpful, but definitely not required, and we'll show you a couple examples. You do not need a welding fixture table, Season 2, Episode 7.
Warning: flashing lights occur during this video. Please use caution. The content and techniques you see in this video are performed by professionals. We ask that you do not attempt at your own risk. Thank you.
Voiceover is in session. This is a gate operator stand. I'll explain it a little bit more, but 6 parts I'm building. This is the 6th one. I already tacked up 4 of them. Mitered corners using the fireball tool square to clamp and fabricate these parts, I guess. Now the way I like to do it is I like to take 2 corners like that and weld them together, and then I'll take the other 2 and weld them together, or tack them together, and go from there. It kind of gives you a little more whatever to fudge with the corners and everything. You could open them up, fudge them a little one way or the other, and go from there, just like that. Those 2 corners like that, or like an L piece and the other L piece. And that fireball tool square, you can see it's coming in handy. Makes it pretty accurate right there. As long as your cuts are good, it should be pretty good. And I'm using that long clamp right there, vice grip clamp, to clamp both of those 2 parts down instead of using 2 separate parts. So you can use a little flat bar like that to help with that. So just getting them all tacked up, ready to go. Not much to it. Just double check your parts, make sure they're square and on measurement, and you should be pretty good. Good thing about that fireball tool square too is you can always open up your part a little bit more, and it keeps it clamped and squared and not sucks in or anything. So here's that's tacked up. That's the top piece right there, nice and beveled, and it'll get ground down after it's done welded. So that black part right there is the finished part. That's a gate operator stand. Now I'm just tacking them all. They're already tacked together, so now I'm going to start welding them. And I like to weld these corners right now. Now one thing I like to do is I like to put a chamfer on right where I'm welding. So right before I welded that, I took the flapper wheel and knocked a little flat on there. So now after I weld these, I could grind them, and I'll still have good weld material in there. But this is how I like to weld them. I like to do the corners first of any square, rectangle frame like this. Feel like that gets it good. Then I'll do the top or the other side or whatever. Now I like to save the insides for last of anything. I feel like the insides pull more, even though this angle and it's a little different. But I'm welding towards the outside because that's just the way I was taught. Heat metal shrinks in the direction of travel, or weld metal shrinks, whatever, in the direction of travel. So if I weld it towards the outside, hopefully it won't pull in a little bit more, if that makes sense. So I welded the top. Now I'm welding the bottom side. Now the bottom side isn't beveled, so it doesn't really matter. It's not going to get ground down, but the top was, so I wanted to add a little bit more filler metal in there just in case. So this, you can see, looked like I dipped the tungsten already. See that little black spot on there. And a little harder to get into these little corners like this. You got to stick your tungsten out a little bit more, especially that corner, the inside corner right there. That's a lot harder. Alright, final product right here, or at least the top part of it. Inside welds won't get ground down, but those corners will, and the tops will. I guess it would be the flats of the angle. Yeah, I tried doing the best job I can. I mean, they're gonna get ground down at least, and people aren't gonna see the insides of it, but still I like to do the best job I can and in a timely manner. So on to the grinding. Now I'm using a flat disc for this. Usually I use a white rock. It's like a hard rock, but a little softer. It's white. And it cuts it down a lot faster, especially if you have a lot of aluminum to do. Now I usually only use that on aluminum, sometimes stainless. It's not as aggressive and it doesn't gouge the metal down as a lot, but I still go over it with a flap disc after. And this is probably like a 60 grit flap disc, and I just want to make sure not to dig into the metal too much and just make it nice and good and go around it. And yeah, not much to it. You can see just blend it in pretty good, and these are going to get powder coated anyway, but I don't want to leave any scratches in it. Now on to the next thing is they're all ground down, so now I'm going to drill some holes in this, kind of center that up, and use those, whatever you call them, transfer punches. And I do a light little tap with the transfer punch. Now I'll go over it with that center punch after and give it a good beefier tap, so I have a nice hole to drill through and go through them all. Alright, now we'll start drilling. Looks like I had Sergio drill them, and I set up the tripod for like a time lapse or something. And we started out with a 1/4 inch bit. I think we worked our way up to a 1/2 inch. I don't know if I showed that or not, but just did it in 2 drill bits. And you could do it in 1, and if you don't have a drill bit sharpener, use some oil on there or WD-40 and make your bit last a lot longer. Now we'll start countersinking these, and I'm just using a larger drill bit that's like a 3/4 or something like that, and just lightly going over it. And make sure you have a sharp drill bit if you do it like that, and works really good if you don't have a countersink or a sharp one. Alright, now I'm just using that template that I have right there. That's actually a template on where to drill the holes for, because it goes for certain motors and stuff, but I have it marked, but there's actually a front and a back towards that thing, and I didn't mark the square tubing before when I center punched them, so I didn't really know which sides front and back where that tubing goes. So just putting a little mark on the back. Now I'm going to start putting those little angles in and square tubing. So I want to find the center of it and do a little standoff. So say that's 4-inch square tubing. I'm not sure if it was 3 or 4, but just say 4. Now I'll go 2 inches each way, plus I guess a 1/4 of an inch for that tubing. So 2 1/4 each way. Find the center of that square tubing. Even though that doesn't really matter, it just shows me that it's in the center. The other marks should be fine. That's just a little extra insurance. Make those lines a little longer so I could see them with that straight or square. Now I'll put the pieces in, kind of check it to make sure it's square, which doesn't really matter. It should be pretty good with the lines. Clamp those all together with 1 clamp. Now kind of clamp that other, or clamp the frame thing down to the table. Now I'll try clamping this to the back of it, and hopefully that should be pretty square, but I'll check it with a level and we'll see. Put a couple more clamps on it and just double check everything. Double check it with the table. Make sure everything matches up pretty good. If your table's out of level, just make sure it matches with the table level or whatever. And yeah, get the welder ready and start tacking it. Just tack everything, make sure it's all good. Double check afterwards how your level is after you tack it. And yeah, I don't think I really mentioned what these were. Sorry about that. Gate operator stands, and a motor gets mounted to the top. Now these go into like a parking lot or something towards the back where you need like a private entrance or something like that, or they just open it with an electric motor. So they get put in the ground, an electric motor goes on top of it, and maybe a chain or something goes to the gate and just opens and closes it. Not much to it. And yeah, so just double check that, made sure it was level after it was pretty much tacked up, and I unclamped it from the table and all tacked up, and that one is pretty much ready to go. Alright, this one I'm going to do a little bit different in case you want to take that square tubing out, and I'm just going to show you something which really it's not necessary for this, but I'll show you anyway. Mark my center and do my little standoff 2 1/4. Draw my lines a little longer with the square just so I could see. And now I'll put these, or clamp it down to the table, put my little squares in, or angles, whatever you want to call them. And you can kind of see right there how that that 2 1/4, that extra 1/4 was right there. But now I'm going to shim it a little, because if I was to tack it all, it might suck in a little and I wouldn't be able to get that tubing in or out if it was in there. So if you shim it a little, it's going to make it a lot easier to get in and out. So just a future tip for everybody, but I'll put like an 1/8 inch shim in there, so that's pretty much 3 or 4 and an 1/8. I guess it was really 3-inch tubing, because that's 1, 2, 3 blocks. But yeah, I put a shim on each side, so it might have been like a 1/16 inch shim or a 32nd or 16 gauge, whatever like that. And it looks like I didn't have the Fireball shims at the time, or I might have brought mine home. So this is an older video, I guess. Alright, clamping it down a little differently now using the Fireball square. That just gets it a lot more accurate. It's like plus or minus 0.004 of an inch, those squares. But here you could see that long reach clamp, it didn't reach all the way in like that, so I had to reposition it. So that's just something to think about with tabletops. Now, if this was like our other table, the fixture table, we have a frame going all the way around the whole thing, and it's like a 3-inch tubing, and I wouldn't really be able to use those clamps anymore, so we'd have to use like a C-clamp, which really wouldn't work. So it just goes to show you how you design your table really matters, and think about how you're going to use your clamps. Especially if it's a fixture table, it really doesn't matter, but I noticed that on our fixture table, sometimes we'll have to use like a C-clamp or a Big Bessie clamp, and it's a lot harder to clamp on the outside of the table. Anywhere on the center it's fine, but just on the outside, if you have that big frame like that, you have to reach over the thickness of your table and whatever that frame is underneath. So those vice grip clamps, all those standard ones, they wouldn't really work that good. So if you already have a table, you already know your challenges and benefits and negatives, and if you're building one, it's something to think about. And I know I didn't really discuss a table too much in here. It was just a little project, and I added a little voiceover of some plus and minuses. I just wanted to get this video out of my library and help share it with you guys. And I'm not the best with voiceovers, but hopefully you guys enjoyed it. There's the final product, and the motor gets mounted on top where that square is, and it'll all get powder coated. And yeah, thanks for watching. See you guys later. Chris Winarski, over and out. Oh yeah, if you could do me a favor too, if you're not subscribed already, please subscribe or like the video. I'm trying to reach 1,000 subscribers by the end of the year. Not sure if I'll hit it, but that's my goal. Thank you for watching. Feel free to like, dislike, comment, and subscribe. Check out my Instagram where I post more often at Chris Winarski. See you on the next one.